All right, guys, welcome back. So, we're going to take a look now at this practice that I asked you to do. We were going to write some formulas for the compounds made from the following ions. So, the first thing we need to do is figure out what these ions are. So, we wanted to talk about sodium and chlorine. So, sodium, again, is Na. He's an alkali metal, so he's going to be an Na plus. So, Na plus. And chlorine, again, is going to be over here. He's going to be a Cl, and being a halogen, he's going to pick up one electron and be a Cl minus. So if I have an Na plus and a Cl minus, I have one positive, one negative. So those are going to come together and give me NaCl. Okay. Now, if I have potassium and bromine, again, I have potassium, which is K. He's an alkali metal. He's going to be a K plus. Bromine, being a halogen, is going to be Br minus. Right? Picks up one electron and be a Br minus. And those come together to give me KBr. Pull that down here. KBr. Okay? One of each. Lithium and fluorine. Again, lithium is an alkali metal, so he's also going to be an Li plus. Fluorine, being a halogen, is going to be an F minus. So if I have an Li plus and an F minus, he's going to be an LiF. All right. Rubidium and iodine. Rubidium is this next guy down. He's an Rb. He's still a plus one. So he's Rb plus. Iodine, again, halogen. He's I minus. So I minus. Those will come together to give me an RBI. Okay. Cesium and astatine. So cesium is this guy. He is a CS plus. And astatine is this guy right here. He's AT. He is also a halogen, so he's going to be an AT minus. So AT minus CSAT. And one thing about the way that these are written, it's always the first letter is capitalized, the second letter is small, so we can't have, we can't write this as C and then capital S because that's carbon and sulfur, not carbon, not cesium. Okay, so watch your capitalization for that. Francium and Tennessine, I can't say that, Tennessine. So francium is here. He's Fr. He's still in that alkali metals. So see, he's Fr plus. And that guy right here, he's Ts minus. Okay. And if I put those two together, that's FRTS. Okay, so all I'm doing is looking to see where is this thing on the periodic table. Based on where it is, what is the charge? And then how do I put those two things together to make sure that that's neutral? Okay, so taking a look at the next group, we have beryllium. Okay, beryllium is right here. So he is a 2 plus, Be2 plus. And my sulfur, okay, sulfur is right here. He's going to be a 2 minus. That's going to be BES. 2 plus, 2 minus, so BES. Magnesium is this one right here. So he's going to be a 2 plus as well. And then we have selenium. So selenium is Se. He's also going to be a 2 minus. So that'll be an MgSe. Okay. Again, at capital S, small e for that. Calcium. This guy right here, he's in Ca2+. And then we need polonium. So polonium is actually this guy right here. He's at PO and he's going to be a 2- because he's also a chalcogen. PO2-. So that's CaPO. Okay. Strontium and livermorium. So strontium is this guy. He's a 2+ also. And then livermorium is this one right here. Livermorium. He's also going to be a 2-. LV 2-. And so SRLV. Those 2+, 2-, those go together. Barium and oxygen. All right. So barium is here. He's going to be a 2+. Oxygen. He's a chalcogen, so he's right here. He's going to be a 2-. BaO. And then we're looking for radium, which is this one right here. He's going to be a 2+. And tellurium. So tellurium is this guy right here, Te, and he's going to be a 2- as well. So RaTe. Awesome. Okay, so now we're going to do some combinations with things that we've already worked with. Okay, so we're looking at potassium, which we had over here. So potassium was this guy right here. Remember, he was a K+. So we had him as K+. And then livermorium, we found him right here. He was in this group right here, and he was a 2-, right? So livermorium was here, 2-. So if he's a 2-, and if I put that K+ with that LV 2-, I'm going to take the charge that's here and put it as a subscript there. So K2 and then LV1. And we can leave the 1 off, and so we get K2LV. All right. And that is our balanced formula for that. Okay. I don't need to write this part right here. I'm just using it to make sure that I get my formula correct. Okay, all I need is that K2LV. Now, rubidium, and I wrote rubidium right here. He was Rb+. And then tellurium, and we found tellurium. He was this guy right down here. He's Te2-. So I'm going to have Rb2Te. That looks familiar. Just like what I did the last time. So I have that 1+, the 2-. I need to have 2 Rb's for every Te2-. Francium. We need francium over here. He's an Fe or Fr+. And then we want that with sulfur. And sulfur we did over here. He was 2-. So again, we've got an Fr. He's a +1 and an S that's a 2-. So we need to do Fr2s. I hope you're noticing a pattern as we do this. So our positives are 1, our negatives are -2. So we need to have that positive subscript 2 and our negative subscript 1. Sodium we had as Na, and of course that Na was a positive. And then our oxygen we had as O, he's right here, O2-. So Na2. 2O. We have lithium, which we have as Li plus. And we have selenium, and our selenium, we found him, he's right here, Se2 minus. So that gives our LiSe, and it's Li2Se. Okay. And then we have cesium, and we found cesium. He's right here. He's a Cs plus. And then we have our polonium. We found polonium right there. He's 2 minus. So CS2PO. Okay. All right. Let's zoom out a little bit. Sorry, move this in a weird way. Need to go back. There we go. Now, I need to find radium. And I know we found radium previously. So let's see if we can go find radium. Radium was down here. So he's an Ra2 plus. So Ra2 plus. And then we had that tennessine. And we found tennessine. And where was he? I know we found him. Tennessine was right here, Ts minus. So similar to what we just did, now we have 2 plus and 1 minus. So now we're going to have our Ra and then Ts2. So now the 2 goes on the negative one because we need twice as many negatives as we have positives. So now we have our barium. And again, we need to find our barium that we did. And our barium was right here. He's a Ba2 plus. And then we have chlorine, and he's a Cl minus. We have him right there. So we have BaCl2 because of that. And we want beryllium, and beryllium is Be2 plus from there. And then we want bromine. And we had bromine right here. He's Br minus. So again, we write our Be, he's a 2 plus. We write our Br, who's a 1 minus. So we need 2 of those to make that even. Okay, we have our magnesium. And our magnesium should be here. Mg2 plus. So Mg2 plus. And of course, we have bromine with that one as well. So Br minus there. So MgBr2. Okay. We need to find calcium. And I know calcium should be in this column. He's a Ca2 plus. Yes, he is. And of course, I can find him again on the periodic table. If I do that, he's right here. So he's going to be a 2 plus. All right. And again, iodine, we can find him in the table. He's all the way over here, and he's an I minus. We can also find him in this table. He's I minus. He picks up a 1 to become an I minus. So, and so then I have one Ca, and I have I2 to make that even. Strontium, again. Strontium is here. He's a 2 plus because of his place in the table. And then we want to put that with fluorine. Fluorine is here in the periodic table. So he picks up 1 electron. He becomes an F minus. And so it's an SrF2. Okay. Now we've dealt with our plus 1s and our minus 2s and our plus 2s and our minus 1s and +1 and -1 and +2 and -2. Let's see what else we can do. So let's find aluminum. So aluminum is here. Remember, we talked about this guy. And when he loses electrons, because he's a metal, remember, he's a metal, so he's going to lose electrons. And he's going to lose 1, 2, 3 to be like the nearest noble gas, which is Ne. So he's going to be an Al3+. Now, we talked about nitrogen, who's right here. He's a nonmetal. So he's going to gain electrons. And when he does, he's going to gain 1, 2, 3 to be like neon. So you can have an N3 minus. And so that means we're going to have an ALN. Okay, so one of each. Now, when I look at this one, I see magnesium 2 and fluoride. Now remember, when we saw that 2 after it, that means that we've got magnesium, which is Mg, and 2+. That indicates its charge. Actually, does that say 2? Yes, it does. Okay. Confused myself with the G that I put there. And then fluoride, which again, F minus. So we've got our MgF2. Now we have chromium 2, which means we have chromium. And chromium, if we take this off right here, we need to go find chromium. Well, chromium is one of these guys. He is here, so he's Cr. He is listed as a 2, so he's Cr2+. We're bonding him to chlorine, who is a halogen, so he's Cl-. So he's CrCl2. Iron 3, that means I have iron, which is Fe3+, because that's the charge he's got. Fe is iron, he has a 3+ charge because that's what this 3 indicates. And then sulfur, again, is here, so he's going to be a 2-. So if I've got that 3+ and a 2-, that means I go Fe, and I need 2 of those. And my S, I need 3 of those to make sure that I have the same charge. So 2 3+ and 3 2- gives me a total of 6 positive and 6 negative. So Fe2S3 is the way that would balance. Now, I have aluminum again. We just found aluminum was 3+. So I'm going to have Al3+ one more time. Now I want to put it with bromine. And I know that bromine is a halogen. He's going to pick up 1 electron. So he's going to be a Br-. So when I have my Al and I have Br, and of course the subscript on the Al is 1 because the Br is -1. So it's going to be 1 there. And then Br, the charge on the aluminum is 3, so I need Br3. Okay. Now I have copper 1 and bromine. So I'm going to find out what the symbol for copper is. Well, copper's right here. So he's Cu. I know that his charge is 1 because that's what that says. And then my Br is minus. So that's Cu Br. Okay, again, 1 of each. All right, last column. I have iron 2. So iron is again Fe. He's a 2+, and oxygen, which is 2-. So FeO. Since I have the same charge, I only need 1 of each. Vanadium. I'm going to find vanadium. So since I have a charge indicated, he's probably somewhere in the middle. Vanadium is V. All right. So, all right, my V, he is a +1. And then he's binding with nitrogen, who I know is a 3-. And if I don't remember that, I can go and find him. He's right here. I can also find him here. I know you pixel 2, 3 to be the 3 minus. So I have vanadium and nitrogen is 3, so we put the V3, and then the N and the charge on the vanadium is 1, so it's V3N. Okay. Aluminum, again, Al3 plus, and oxygen is 2 minus. So I write the Al first. I know that the charge on the oxygen is 2, so I need 2 of those. My O comes next, and the charge on the aluminum is 3, so it's Al2O3. I just put the charge as the subscript on the other species. Cool. Chromium and iodine. Remember, chromium was this one right here. So he's Cr, and he's a +1 because he says 1 right there. So Cr plus, and iodine is I minus. So that's Cri, because I need 1 of each. Silver 1. Well, silver is this guy right here. He's Ag. Some of these symbols come from words in other languages. I don't remember. I think silver is from Latin, but I can't be sure. So Ag plus, and then we have oxygen, which is O2 minus. So we've got our Ag. I need 2 of those because of the oxygen, and then we have O and 1 because of the charge on the Ag. So Ag2O. And then magnesium 4. Magnesium is this one. He's +4. Okay, happens sometimes. So it's Mg4 plus. And then bromine, Br minus. So we've got Mg Br4. Okay. Cool. So that is all of the practice that we were talking about there. Do we have any questions about how we found our symbols, how we found our charges, how we make our formulas even, how we do any of that? All right, I hope not. But if you have questions, let me know. I will be happy to walk through any of the things that I did here and answer any questions that you have. I'm going to take another break, and we will come back to this in a bit, and we'll pick it up here. Thanks, guys.